Hello, in this video we're going to talk about filling our gas cell with oxygen gas. So we have an oxygen gas cylinder. So a few important parts here. We have this little cell here, which connects to our gas filling port here. We have the vent valve, which we want to make sure is closed. We don't want to like clamp down real hard, but we do want to make sure it's firmly tightened. And then from here, this valve here is the vent valve for the gas line. We want to make sure that that's closed. And then we want to make sure the gas cylinder is open. We can usually tell a cylinder is open if we have the gas. This is how much gas is in the tank. This is how much pressure is in this line here. So no pressure yet in the line and a reasonably full tank. So we're going to turn this valve pretty slowly. You know, depending on who used it last, it may be cranked down kind of hard. There's a little bit of give and take. So it's not until I get to here that I can then begin to open. Just open slowly. Take it to about 30. You're looking here. Take it to about 30 atmospheres. Now this is a pretty high pressure of gas. We'll stop at 30. Tighten down again. Don't go super tight, just enough to tighten. This is now the pressure in this line here, which we're assuming was the pressure inside our calorimeter as we were filling, since we filled relatively slowly. Now, if we went ahead and did our experiment right now, we would still have some residual N2 from air that was originally in the calorimeter. So we can flush that air out, our air and our oxygen gas. And then we can refill it once again. So we don't want to go necessarily super fast with our venting because it could blow the wire away from the sample. So we want to take our time. We don't want to like take necessarily 2 minutes to vent, but you know, maybe like 10-15 seconds to vent the calorimeter. Then we close the valve back up and then refill. So we're filling back up to 30. Actually, I think the manual says 35. So we'll go to 35 psi, or atmospheres. That's important for me to make the distinction. Atmospheres is what we're measuring here, not psi. About 15 psi is 1 atm. So this is 35 times about 15 psi. This is an extremely high pressure of gas. Now, before we remove this valve here, what we want to do is vent our line. Gives us a hiss. And then we can remove very easily. If you don't vent the line here, what's going to happen is you're going to still have that high pressure, and you're going to hear, you know, the popping sound as you take this line off here, and it might, you know, scare you a bit. So just vent here, and then remember, before you fill, close here. Okay, so that's filling the cell. We'll go ahead and move on to the next part, which is placing the cell into the can. I should say, it's probably a good idea to wear gloves when you're handling this experiment, mainly because you just want to keep the greases from your hand off of the equipment and try to do things reproducibly. So if you're wearing gloves, it's probably a good idea. So now we moved over to our water filling station. So this is the 6510 water handling system. This tank holds about 20 liters of water. This is actually called a pipette, but this pipette here holds 2 liters of water. And it's a very reproducible way of adding the same quantity of water repeatedly throughout our experiment on different trials. So what we want to do is go ahead and fill our cell. Now, to fill, this valve stem here is a 2-way valve, and it's in the fill position. You can kind of see the water spilling over, water filling in from the bottom through the top, and up here, draining out back into the reservoir. This also is capable of maintaining a constant temperature. So you see the temperature changing. The temperature set point is 22 degrees. I just turned this on a little bit ago. So this is trying to keep water around 22 degrees C. And so then all we need to do to add water is simply flip the valve 180 degrees, and then we are draining the water. And the way this works is you can probably barely see that there's glass up to this tip. So when water fills the tip, it can then, from that tip downward, is the precise amount of water that's going to be added every time to our bucket. And so this gets us about plus or minus 0.3 milliliters in terms of the precision. If you think of getting plus or minus 0.3 milliliters, that sounds like still a pretty big uncertainty, but if you think of how you might do this with other ordinary glassware, more precisely is going to probably involve using several, maybe 100 ml pipettes multiple times, which is going to be painful to do or tedious. And then if you think of larger glassware, most of your bigger glassware, like big graduated cylinders, are usually designed and calibrated to contain that quantity of liquid, not necessarily to deliver it. This piece of glassware is designed to deliver that precise quantity of liquid. So it's just about filled. And you can see it's filled almost to the top. Now what you want to do is just, get the last couple drops out. If you think about it, that's your plus or minus 0.3 milliliters, is having a reproducible technique of getting those last couple drops out. And then we transfer this cell to the big thermos area. Now, if you can see, there's a little bit more area in the front. We want that here. You'll see why in a second, as opposed to if I flip this 180 degrees, we don't want it this way. So we want more area towards the front of us. So we add this. And now, without trying to touch the water, we just want to connect our lead wires. It doesn't matter which one's red, which one's black. If you see a few air bubbles periodically coming up, that's just some trapped air escaping from the cap on the cell. If you see a steady stream of bubbles emerging from the calorimeter, that's a problem, and we should address that if that happens. So again, if you see a few bubbles that then pause, that's just some trapped air escaping. If you see a steady stream, we'll talk about how probably disconnecting and redoing the experiment might be worthwhile. Okay, and so the last thing I'll show in this particular video is connecting here. This is the reason why we want more area in the front, is so that we can have room for the mixing motor in the front and then the thermometer in the back. Okay, I need to use two hands to do this step here, so I'm going to go ahead and stop, but we just would add here, and I'll show the connected cell at the start of the next video.